Managing database performance. In this nugget, we're going to look at some advisors, yet again, more advisors in the Oracle Advisory Framework that teach us how we can better plan our SQL for maximum performance. We're going to learn how to use two advisors in particular, the SQL Tuning Advisor and the SQL Access Advisor. Now, these two advisors, as we're going to learn, do some of the same things, but it's important for our exam success that we understand the use cases that would point us to run one above the other. We'll also take a look at a niche feature of Oracle Database 11g called Database Replay. This, along with Access Advisor, involve what's called the workload specification, in which we take a sampling of our real-world Oracle application performance and we replay that in order to do performance tuning and troubleshooting. Let's get to work. First, let's have a look at performance tuning in general. What does this mean? There are folks who make their entire careers working as Oracle consultants, helping Oracle database to run as efficiently as possible. Now, tuning activities according to Oracle, we'll call this performance management to use a generic term, involves three key areas of concern. We have performance planning, instance tuning, and SQL tuning. According to Oracle, performance planning is establishing the environment for Oracle. In other words, we're looking at hardware, software, operating system, network infrastructure, and so forth. Instance tuning deals with adjusting the Oracle initialization parameters and associated operating system parameters to make sure that Oracle has what it needs and is running as efficiently as possible. And then finally, SQL tuning kind of bleeds over into application tuning, such that we're looking at the statement level as well as how the application runs as a whole to make sure that our application is running healthily. Now, Warner's Law of IT, or should I say Warner's first law of IT, is that you'll always receive complaints from some users who claim that the system is not running fast enough for them. That's just one of those things. That having been said, Oracle has some great suggestions for tuning, some general suggestions that are based on their experience not only as a first-party technology provider, but also as an implementer and through their work as consultants. Microsoft is the same way in terms of sharing best practices. Really good stuff here. And when you think about it, Oracle and Microsoft, to pick on both of them, are doing us as administrators a great service by sharing their best practice suggestions, but they're also reducing their own support costs by giving us DBAs as much grist for the mill, so to speak, as much stuff to work with as possible. Now let's take a look at what Oracle calls top-down tuning. Now what does that mean? So top-down tuning means that we start from the application design. When we're looking at maximum efficiency for our Oracle database, we need to look at the associated application. Now this, of course, refers to your line of business application. This could mean one of Oracle's own application server suites, or it could be a roll your own or another third-party off-the-shelf solution. But here we're looking at OS statistics along with the actual architecture of our application. For instance, Oracle suggests that we try to look at and investigate full table scans that are resulting in I/O contention before we look at the larger picture of how our table spaces are set up on disk. You see, to do that, of course, goes into SQL and PSQL code and how that's tying in with our operating system setup. So that deals with steps 1 and 2. Basically, top-down means look at the biggest picture first and then gradually drill in. So operating system, application design, application code, then we get down to the instance, initialization parameters, and so forth. And then finally, we get down to the granular level. What's going on in terms of individual SQL statements? Are people getting hung up? By people, I mean our application users. Are they getting hung up waiting for SQL to complete behind the scenes? By contrast, is poorly coded SQL resulting in untoward resource consumption on our Oracle server? One point that I really respect about Oracle's troubleshooting methodology is that they stress quantitative statistics. Now that doesn't mean that intuition doesn't count. I mean, we want to trust our users when they call us and they say that the application is performing slowly. We may replicate their problem and have a hunch, yes, it does feel like this application is running poorly. I wonder what the problem is. Well, we're definitely going to want to gather quantitative or numeric proof of a poorly performing application and poorly performing Oracle before we move forward with formally identifying the root cause and then proposing a solution. Let's take a look at performance management to a little bit greater degree, again revisiting those three main classifications: performance planning, instance tuning, and SQL tuning. By the way, the look of this slide is a little bit different. What you're seeing is the result of a really awesome website that Dan, my boss at CBT Nuggets, turned me on to. It's handfont.com. And just to say a word about this, because quite honestly, future nuggets in future series of mine are going to feature handfont. This is an online web application where you can send them a sample of your own handwriting and they will develop a true type font for you based on your own handwriting. Is this example that you're seeing here exactly matched to my handwriting? Well, yes and no. Every glyph or character you see on the slide does come from a sample of my writing, but I must say what they give me here in terms of normalizing the letters and adjusting them, etc., is much more legible than you have with my actual freehand. So I hope you like it. Send me email with your thoughts. Anyway, let's get to the content of the slide. Oracle's take on performance planning involves answering questions like, how much money do you have to spend? Remember in an earlier nugget when we were dealing with memory, I mentioned that just installing more RAM in a system alone isn't necessarily going to guarantee you anything with regard to performance with Oracle. Similarly, throwing money and hardware at your server is not particularly well advised. You want to make strategic decisions. Basically, to come down to this third point, we want to balance cost, the cost of adding hardware, software, or man hours, people hours to use the politically correct term, to improve the performance of Oracle, with what benefit we'll get in terms of speed, higher efficiency. But we also need to be ever vigilant about maintaining system reliability. I can give you a good example. We determine that the system, the Oracle system, needs more RAM. We make a RAM choice based on cost and by the cheapest RAM we can get. Turns out we crash the server and cause additional performance problems in the short term until we identify that the RAM we purchased isn't as good as it should have been. Problem solved, etc. But that was a hard lesson to learn. We don't want to sacrifice reliability in the name of cost, nor do we want to try to go for maximum speed while spending too much money and again sacrificing reliability. Another question in the planning aspect is, how well can your application scale? If you have a homegrown line of business application, one key driver for that is scale. In other words, as you add an increased workload, does the application still perform up to snuff? And that up to snuff, according to Oracle, is going to be a quantitative measure. You don't just want to say, I want the application to perform okay. You want to say, I want the application in Oracle to be able to transact 100 transactions a minute or 100 transactions a second. Whatever your scale is, it's up to you. But as you increase workload, you want Oracle and your line of business applications to match and maintain reliability, maintain speed. That brings up the importance of workload testing, some of which is what we're covering in these exam objectives. In particular, the SQL Access Advisor and the Database Replay feature both deal with taking real-world workloads, in other words, actual transactions that come about on your line of business systems, and replaying and analyzing those to do performance tuning. With regard to instance tuning, we finally come to the formal suggestion from Oracle to have clearly articulated goals, put numbers to those goals, and stop tuning once you've reached those numbers. One hazard that some DBAs have with performance tuning is that they overtune, become sort of obsessed, and you not only get your system running to where you had envisioned it would be, but try to push it further. Again, bad idea. You may wind up spending too much money, ultimately hobbling speed, and even worse, crippling the system's reliability. So have clearly articulated goals, stop when you've reached your goals, and also make sure to never underestimate OS performance tuning as well. Sometimes there's that line in the sand, especially in larger distributed shops, where you are a DBA and that is where your responsibility begins and ends. In other words, you can't step over into the system admin sandbox and start tweaking operating system hardware and software parameters. This is going to be where diplomacy and good communication skills come in. And again, it ties into quantitative data because you'll want to present to those system admins in numbers and projections for system improvement and lowered support cost by making those operating system changes that support your Oracle database. Final suggestion deals with SQL tuning, and here we're suggested by Oracle, obviously enough, to use the advisory framework. As we've seen in this Nugget series and in my other Nugget series that we've done for CBT Nuggets, Oracle has an incredible amount of self-management where you can turn on an advisor, have one or more Oracle processes scrub through data, scrub through your system's hardware and software and file system, and come back with really nice suggestions. You don't necessarily want to blindly take all of Oracle's own suggestions, but because Oracle itself has a really nice moment-to-moment handle on what it's doing, I would suggest that you do take advantage or take those advisements under advisement, if you don't mind the word salad there. Let's continue. Now, in our CBT Nuggets course series on DBA1, the DBA1 test, we fully define AWR. Here, I'm just going to refresh your memory. The automatic workload repository is a feature of Oracle database that collects and stores performance data and statistics. We know that statistics are the intelligence that Oracle uses when it builds execution plans to satisfy your queries and to execute your PLSQL packages. So AWR is really a crucial part of Oracle database. It records and stores its findings to data files in the sysaux tablespace, and the MMON, the Manageability Monitor background process, creates snapshots of the system state on an hourly basis by default. Another process called the ADDM parses and analyzes the statistics, the raw data that's collected by AWR and MMON, and reports those to you through the advisory framework and through just the automatic diagnostic repository that we looked at earlier. We can get to AWR directly and indirectly through Enterprise Manager as well as PLSQL APIs. We're going to focus on the Enterprise Manager solution, but I will give you the names of relevant PLSQL packages as we work through this nugget. Now, what about this SQL Tuning Advisor anyway? Basically, SQL Tuning Advisor runs automatically during your predefined maintenance windows. Typically, that's going to be at night. It's going to run an automatic job for you every night and analyze the performance of high-impact SQL. More than one means that the Tuning Advisor takes action on SQL statements individually, but you can throw entire batches at it if you want to. That actually is a key difference between the SQL Tuning Advisor and the SQL Access Advisor. The Access Advisor is meant to work with a workload, where you're throwing a whole bunch of transactions, some of which may be linked, others may not be. It could be just a number of different transactions flying at Oracle from a number of different directions. SQL Tuning Advisor, by contrast, we're looking at each SQL statement as an individual atomic unit. The suggestions that the SQL Tuning Advisor can give back are recommendations for new indexes or alterations to existing indexes, SQL profiles, suggestions for gathering additional statistics, and even tips on restructuring your underlying SQL code. Isn't that amazing? That SQL can teach you, in a sense, to become a better SQL developer in Oracle. Now, I mentioned that this job runs automatically during your maintenance window. We also can run the Tuning Advisor ourselves against specific statements. There are several sources, data sources, that we can feed into Oracle Tuning Advisor. The modes of operation are going to be the suggested way through Enterprise Manager, where everything is graphically presented. Or if you're a glutton for punishment, you can use the DBMS SQL Tune PLSQL package. Now, as you've come to expect, and as you know, behind the scenes, when you set up a Tuning Advisor job, what's actually happening is that you're formatting input parameters and executing DBMS SQL Tune. As a matter of fact, I'll show you in the demo that we can always reveal the underlying SQL and PLSQL code through Enterprise Manager. That's a really nice learning tip for you, actually. The final thing I want to say about the SQL Tuning Advisor before we move on to Access Advisor is just to formally state those data sources that we can feed feed in. One thing we can do is feed recent activity pulled from the library cache of the shared pool. That's where our recent SQL is going to be stored in the SGA. We can give it a pre-created set of SQL statements. We can dip into the automatic workload repository or AWR history. Or finally, we can just feed it an individual ad hoc statement. In other words, just literally compose the SQL right there and hand it to the tuning advisor. SQL Access Advisor. What Access Advisor does is it performs an analysis for us of overall SQL performance using a workload. A workload can consist of a single SQL statement, the contents of the SQL cache, or, this is the best practice, an SQL tuning set, which is essentially a saved collection of SQL with its associated statistics and execution plan. In fact, in the demo, we're going to create a tuning set and then send that to the advisor. This is something that you'd want to work out with your, or maybe actually delegate to your quality assurance and testing folks, such that they can create a tuning set that replicates the typical user workflow through one part of your application. Capture that, send it into Access Advisor. Basically, you create the task, you define the workload, give it to Access Advisor, it generates recommendations, and then you implement those recommendations if you want to. The modes, again, are similar to SQL Tuning Advisor. We have the Enterprise Manager front end, or we can use the DBMS Advisor PLSQL package directly. It's up to you. As far as the recommendations that come back, new indexes, partitioning for large tables, and also suggestions for materialized views. Those are the three categories, and those have really big potential impact when you think of a workload. All of these deal with faster data access, don't they? Materialized views, which is a view that actually has the row data in addition to the results of a stored query. Partitioning, that spreads a large table over multiple areas. And of course, we all know indexes improve lookups and prevent long-running table scans. The final subject of this nugget is database replay. And basically what we've got going on here is capturing, recording, so to speak, a live workload on your production system and replaying it in a development environment. Common use cases for database replay are upgrades, hardware upgrades, software upgrades. This could be a patch to Oracle, or it could be an upgrade, a service pack, or a revision to the host operating system. Could be a code change in your line of business application, but you're basically testing here to see how an existing workload performs under that new rubric. So in our development system, we might have a mirrored database set up exactly the same as our live system. We make the hardware change over here in development where it's safe, and then bring over that workload that we've captured from our production system. And the idea is if everything proceeds okay, we have at least more comfort in making that analogous change on the production side. And it's a four-step process. You capture the workload on the production side, pre-process, make tweaks to that workload, bring it over to development, replay the transactions, and analyze it. There's a lot to database replay. We're actually not going to demo it. I've given you everything you need to know here with regard to questions you might see on database replay on your certification exam. I will say that the associated PLSQL package here, just for completeness, is DBMS workload capture to at least get you started. Hey there, welcome to this demonstration on performance tuning in Oracle Database 11g. Here we are on our Windows Server 2008 R2 server, or a nugget, and we're actually going to do this backwards. We started with the SQL advisors, and then we discussed database replay. I mentioned in the whiteboard portion of this lesson that I wasn't going to fully demo database replay here, and that's true. Nonetheless, I just want to give you a heads up on how to find the option in Oracle. That's always everybody's first question. Where is it in the interface? How do I at least start the process? Well, number one, you're going to find that you're hosed unless you've installed the Real Application Testing optional component. So make sure when you install your production and test databases, when you get to this page in the Oracle Universal Installer, under Select Options here for the Enterprise Edition, ensure that Oracle Real Application Testing is installed, because if it's not installed, you won't have access to database replay. It's as simple as that. Now, I do have Real Application Testing installed on my machine, so I'm going to navigate over to Software and Support, and then under Real Application Testing, we have Database Replay. And it's a nicely documented interface. I'll just get you started off here. You'll you'll note that the process, which is very time consuming, quite honestly, is devoted, or should I say divided, not devoted, into tasks or phases, which I mentioned to you earlier in the whiteboard. One, we capture a workload from the production environment, and that this can be scheduled to accommodate a restart if desired, and then we can go to that specific task. Number two, pre-process the workload. We prepare the captured workflow for replay. We have to do this for each workload. And then finally, on the dev machine, we replay it. Now, it's assumed that your dev and production databases are clones. So actually, if we mentions that in one of these tasks, when you start a task, you're asked to acknowledge the prerequisites, and you'll notice in the capture workload plan environment step, it tells us here, make sure we can restore the replay database to match the capture database at the start of the capture. A successful workload replay depends upon the transactions making the same calls. That's just common sense, right? Common ways to restore include point-in-time recovery, flashback, and import-export. We know about all this because we've covered those earlier in the training. So that's the skinny with database replay. That's all you need to know, number one, for your exam success, and two, to at least get you started in using that technology if you want to. What we're going to focus on primarily in this demo are the SQL Tuning Advisor and Access Advisor utilities. Now, to use the SQL Tuning Advisor, one of the options for input is what's called a tuning set, and this is going to be essentially a stored query or series of queries that we can basically save along with its execution context and execution plan, and then feed that into the SQL Tuning Advisor. So actually, let me minimize the browser and bring up SQL Developer. I've logged into Oracle as the Scott user, and what we're going to do to walk you through this sample code is we're going to create a table as Scott called Scott Objects that just pulls all the rows from the built-in view All Objects, just to give us some grist for the mill, basically. Next, we're going to execute the DBMS stats built-in PLSQL stored procedure, and we're going to run gather table stats, basically to force a computation of statistics on that new table. We don't want to wait, in other words, for Oracle scheduler jobs to do that. We're going to force that to happen immediately. And then third and finally, we're going to generate some activity. These are simple selects from that new table, and we're adding a where clause that uses various logical comparison operators to pull back rows. Now the trick here, this is all planned out and there's a method to this madness. The trick is object ID, which is being used in all of our queries, actually is not indexed in this new table. Obviously, we just created the table here, for heaven's sake. So that's going to definitely drag the performance of these queries, so we know in advance basically what the SQL Tuning Advisor is going to suggest to us. But, you know, that is the point of doing this lab, to actually take our theory, put it into practice, and compare the results. So my create table statement succeeded. Now let's run that DBMS stats gather table stats run. That completed just fine. And then I'm going to run all of these select statements. Just select them, pop them through. And what that's going to do is populate our cache with that recent activity, such that we can build a tuning set based on those cached transactions. First of all, how do we create a tuning set? Where do we get to that in the interface? A few different ways. One way is to navigate from OEM to the Performance tab, where we see this baseline. We talk about baselines in the DBA 1 CBT Nuggets course. And under additional monitoring links, we have SQL tuning sets. And the documentation helpfully tells us that an SQL tuning set is a collection of SQL statements that can be used for tuning purposes. That's what I would call a tautological or circular definition, not particularly cool. And it gives us a list of any that we've created. I already have one created called My Objects Query. I was doing that as a test. And you'll note that when you have a tuning set set up, you can feed it directly into SQL Tuning Advisor or Access Advisor directly. These are very helpful buttons. What we're going to do actually, though, is start the Tuning Advisor independently and then come in sort of through the front door rather than the back door here. To create a new tuning set, we'll click Create. It asks us for a name. I'm going to call this Scott_objects_query. The owner of this is sys. I'll leave the description blank and we'll go next. Load methods. It asks us, how do we want to load that data in? Do we want to incrementally capture active SQL statements over a period of time and stored in the cursor cache in the library pool? And if you do that, you can sample over a duration. The default is to sample over a 24-hour period, frequency 5 minutes. This is an excellent option if we want to load in real live data over the course of, say, a workday through a peak period. Actually, I would choose a full workday, or like this says here, 24 hours would work, such that we can capture both peaks and valleys in our database performance. Now, what we're going to do, though, since this is a very still database, is load our SQL statements just one time now, and our data source is going to be the cursor cache. We could also load, as I said during the theory portion of this nugget, from the AWR, or specify an ad hoc user-defined workload. We're going to do cursor cache, like I said. We'll click Next. Now, this is the trickiest screen. It's kind of difficult, cumbersome to navigate. I don't really like it. Under filter conditions, we want to set this up to capture SQL that operates on the table we created, which was, I've already forgotten, let me come back, Scott_objects. I'm actually going to fill that row in first before I forget. And to be sure that we pick up SQL statements that include this string, I'm going to throw the wildcard operator % both before and after Scott_objects. So basically, we're cutting down on the SQL stream that's being picked up by this tuning set. So we're going to run an SQL text like filter. Also, we can cut it down even more by using a parsing schema name, and we created that under the Scott schema, didn't we? Let's click Next. We're asked to name the job. I'll call it Scott Tuning, and we can have it run now, which is the default, or we can have it run on a particular date and time using the scheduler. I'm going to do it now, and we'll click Next, review our information, and then submit the job. So now we have a tuning set. If we click the tuning set, it brings us to the specific contents of that set, shows us exactly what it picked up. Remember, we're looking for the parsing schema of Scott, and we're looking for SQL text that includes the string Scott objects. So in this case, it picks up the create table statement as well as our selects and also our stats gathering. It even tells us the source from where those queries came to us. That's pretty cool. Again, we have helpful links for the SQL advisor, but I'm going to actually come back to my database instance homepage, and like I said before, we'll go into it kind of through the front door. And as you know, we can get to the advisory framework from several areas. I'll go back to the home page, scroll down and come under related links, Advisor Central. Under Advisors, SQL Advisors. And here we have access to both SQL Access and our SQL Tuning Advisors. Now this is interesting. The SQL Tuning Advisor takes us into the tool specifically. Automatic SQL Tuning Results gives us the results of the daily jobs that are run. Remember, I mentioned that the Oracle Scheduler runs this as a maintenance task every day. You actually can customize that from this screen. You see here the task status, that the sys auto SQL tuning task is enabled, and we can configure that if we want to. And this is the default maintenance window right now. We can edit that and go into that to our heart's content. I'll step back. Automatic implementation. As the advisor makes recommendations for SQL profiles, you can actually just trust Oracle implicitly and tell it to go ahead and implement any profiles it recommends. That's disabled by default. You can customize the time period that you're seeing here. Let me scroll up a little bit in summary time period. And then we see finding. I mentioned that the suggestions are SQL profiles, indexes, statistics gathering, restructuring SQL, or developing an alternative execution plan. And you can just go in there. It looks like we've got some stale statistics or references. We can drill in there if we want to. But this is just the result of the last automatic SQL tuning run. To go into the advisor specifically, which we'll do now, we'll click SQL Tuning Advisor, and it asks us for a name, optional description, and you guessed it, an SQL tuning set. I'm going to call this SQL Tuning 1. You want to be descriptive, of course. I'm not particularly so in this case. And for SQL Tuning Set, we don't have to remember its name. We can use the flashlight, the browse icon, and this defaults to the sys schema, and we have our Scott object query right here. I'll select it. It gives us an SQL transaction count as well. We'll bring it in. Let's see if the overview has anything useful that we don't already know. It says that the SQL Tuning tuning advisor analyzes individual SQL statements. Remember, that's the big distinction between the SQL tuning advisor and the SQL access advisor. Access looks at a workload as a whole. If we scroll the page down a little bit, we can set a schedule immediately. There's really nothing else we can do. We can cut the scope if we want it limited or comprehensive in scope. If we want it to pass, if it spends a certain number of minutes on a single statement, it can go ahead. If it exceeds that time limit, 30 minutes is the default total time period for this job, and that's fine. It's going to be able to complete it a lot sooner than that. It starts the job, and we just sit here and wait, basically. It automatically refreshes the window. We can interrupt if we want to. When the job is finished, we see a screen very similar to one I showed you just a moment ago. Now, we knew, remember at the beginning I let the cat out of the bag, that all those queries were hitting the object ID column, and object ID is unindexed. So you know darn well that its suggestions are going to deal with indexing, right? So let's scroll down and see what we've got. Actually, let's click the index item on this chart, and it gives us a breakdown of each of those transactions. And it looks like by adding an index in the recommendation column, we're going to get upwards to 100% increase in performance. And we know that. That's obvious. But sometimes you'll find that you get suggestions that you might not have thought of intuitively. Now you notice there's an implement all SQL profiles, or we can select an individual transaction, view recommendations. And that first statement, select count from Scott objects, it tells us that the execution plan for this statement can be improved by creating one or more indexes, gives us our benefit again, and actually allows you to see, that's what these little glasses are, the new proposed explain plan or execution plan, and then we have a comparison where you can compare the old and the new. Now, of course, on an unindexed table, you're just going to do a full table scan, which is about the most inefficient way to parse a table that you can believe, you know. Now, with an index, you notice that we're going to do an index range scan instead of a table scan, which is going to be a lot faster, like it said. I mean, look at the difference in I/O cost from doing a table scan, 225, to using an index scan of 2. It's unbelievable, you see. So that in a nutshell is what's going on here. You can step back. You see the breadcrumb navigation trail? You can step back however many levels you want, and all of this stuff is hyperlinked. SQL examined with findings, you can just boom, give it a click, and come back to this table like I showed you before, and just view the recommendations and decide whether or not you want to implement that suggestion. Now let's have a look at SQL Access Advisor. In order to generate a little bit more transactional activity, what I've done is Scott is first of all granting select on Scott objects to the HR built-in account. I've then logged into Oracle as HR, and I ran those same queries. Of course, I needed to change the name of the table to Scott.Scott_objects to reference the appropriate schema, but that's just meant to give us a little bit more of more beef, I guess, to our fictional workload. So we'll come back to the home page here and start from scratch. We'll go into the advisory framework, Advisor Central as it's formally called, SQL Advisors, and this time let's check out SQL Access Advisor. It says in the documentation, let's hope that this explanation isn't as tautological as the other one was, evaluate an entire workload of SQL and recommend indexes, partitioning, and materialized views that will improve the collective performance of the workload. So you're looking at, by definition, more than one SQL statement as a group. When we go into SQL Access Advisor, our initial options are to just verify or actually recommend new access structures. I'm going to choose recommend here, and we'll continue. We're asked next to specify a data source. I'm going to use current activity here that we'll pull from the library cache. We could also use a tuning set if we wanted to, or do an ad hoc hypothetical workload. Just do this as a comma-separated list. And then we have a tip for workloads containing a large number of SQL. Oracle recommends filtering. And basically, we did filtering a little earlier when we did our tuning set. Remember, the purpose of that is to reduce analysis time. Basically, if you've got this river of SQL coming in, why devote extra CPU cycles and time to looking at SQL that's irrelevant to your needs and your performance tuning, see? So we'll click next to move to the next step. We're asked which access structures do we want recommendations on. By default, it just stays with indexes. I'm going to choose everything here. And limited or comprehensive means, do we just want to look at highest cost statements? In other words, give me the most bang for my buck with the minimum of time? Or do we want to go all out and run a comprehensive test? Completely up to you on how you want to do that. Give it a name, task description, what level of journaling or logging you want, and then some expiration metadata and scheduling options. The default here, if we just click next, is that it's going to go immediately. And then finally on step 4, we submit the job. Tells us that that task has been created successfully. Of course, we'll want to view the job details. What's interesting here, I told you that you can show the SQL that's being used and the PLSQL calls that are happening. That's happening here. We're using DBMS Advisor and then drilling into that package and running different subroutines within it. So it looks like this job is currently running. We can refresh the page using the refresh button, and it succeeded. Let's click the task name, and down in the log area, we can view its metadata. And stepping back, once you've submitted that scheduler job and it completes, as you saw, clicking around in the schedule interface shows you metadata about the schedule job, but where do we get to the results? It's not all that intuitive. In my opinion, that's a little bit of a hole in Oracle's usability in the Enterprise Manager. Here's what we want to do, friends. We want to get back to your Advisor Central page, which from the Home tab in Enterprise Manager, we can get to down below under Related Links. And from the Advisor Central page, underneath the Advisor links, we have this Advisor Tasks list. And this is where you'll see in reverse chronological order all of the jobs that involve advisors that are either scheduled to run automatically as part of a maintenance task that Oracle has built in, that you've scheduled to run as an administrator, or in this case as an ad hoc operation. So you'll see the very last thing that was completed was our Access Advisor run. And to view its results, select it in the list and click View Result on the toolbar. This brings us to a 4-pane view that shows you some really cool metrics. You know that old saying, a picture is worth 1,000 words? The original cost of that workload versus what it proposes if we take Oracle's recommendations. That's pretty cool. And it says that it can give you a query, or give us, I should say, a potential performance improvement of 10 times or more. It looked at 80 SQL statements. It has 8 recommendations. We can jump to those directly, or we can go over to the Recommendations tab. It's all nicely hyperlinked. I guess I'll go over to the Recommendations tab. Again, we get to the color. Unfortunately, a colorblind person like me, this isn't very helpful, but the indexes, materialized views, partitions are all color-coded, and we can see, depending on which transaction or operation it looked at, it has one or more suggestions. And the idea here is we can schedule an implementation of these, we can show the SQL behind them, we can look at recommendation details. It shows you at a very granular level what's going on, what's being affected by those recommendations, and then schedule implementation is actually going to happen as a scheduler job. And if there are things that cannot be automated, it will tell you. So there it is. I think I've underlined to you in Technicolor just how powerful the Oracle Advisory Framework is. If you're humble enough to accept an application suggestion rather than that of another human being, or at least take Oracle's suggestions under heavy advisement, I submit you can do some great magic with improving the performance of Oracle and come across as a hero to your users, to those to whom you consult, and of course your employer. Managing Database Performance Review. In this nugget, we started with some best practice suggestions from Oracle on how to approach the subject of performance tuning in general. I gave you some tips regarding top-down tuning. In this nugget, we concentrated not so much on the top end of things, but more towards the granular bottom end at the individual SQL statement and workload level. We now understand 2 important advisors in the advisory framework. SQL Tuning Advisor, that looks at individual or groups of SQL statements, gives us suggestions regarding various aspects of that performance. And then we looked at 2 workload-oriented tools, Access Advisor and Database Replay. Certainly Database Replay is the more robust of the 2, where we're capturing a workload on one instance, bringing it over to another instance and replaying it. Access Advisor is probably more up your alley in single database, single instance environments. But the good news is that you have these skills under your belt to master any questions you see on them on your certification exam, and just as importantly, you have these skills to apply in real-world contexts with Oracle Database 11g. I hope that this has been informative for you, and I'd like to thank you for viewing.